Tsunamis are large, powerful waves caused by underwater disturbances. These waves can travel across entire ocean basins, causing massive destruction when they reach coastlines. While most people associate tsunamis with earthquakes, there are several other causes as well. Here's a breakdown of why tsunamis happen. The most common cause of a tsunami is an underwater earthquake, which occurs when there is a sudden shift or rupture in the Earth's crust. This movement happens along tectonic plate boundaries where plates are either colliding, pulling apart, or sliding past each other. These shifts can displace a large amount of water, generating waves that travel outward from the earthquake's epicenter. Subduction zones. Most tsunamis are caused by earthquakes in subduction zones. This is where one tectonic plate is forced under another, causing the ocean floor to suddenly move. When the plate pops back to its original position, it displaces a large volume of water, creating the tsunami wave formation. The earthquake causes the ocean floor to either rise or fall, displacing the water above it. This creates waves that spread out in all directions. These waves travel very quickly, often at speeds of up to 500 to 800 kilometers per hour, but they are usually only a few meters high in deep water, so they're not easily detected by ships. Tsunamis can also be triggered by underwater volcanic eruptions. When a volcano erupts beneath the sea, the rapid movement of magma, gases, and ash can cause the ocean floor to collapse, or the water above the eruption to be displaced. This leads to the formation of tsunami waves. In some cases, volcanic eruptions cause caldera collapse, where the top of the volcano suddenly collapses into the ocean, displacing water and generating a tsunami. Another cause of tsunamis is underwater landslides or landslides into the ocean from land. These can be triggered by large earthquakes, volcanic eruptions, or even the collapse of glaciers into the sea. When large amounts of debris fall into the ocean, they can displace water, sending waves across the ocean. For example, if a massive chunk of land suddenly slides into the ocean, either from the shoreline or from the ocean floor itself, it can cause a sudden displacement of water that forms a tsunami. The 2004 Indian Ocean tsunami, in part, was caused by both an underwater earthquake and a landslide in the region. In some extreme cases, the sudden collapse of large glaciers or ice shelves known as calving can trigger tsunamis. As massive chunks of ice break off and fall into the ocean, they displace water, causing waves that can travel long distances. This type of tsunami is rare but has been observed in polar regions where ice sheets meet the ocean. Antarctic ice shelves, for instance, have calved large icebergs into the ocean, which could lead to local tsunamis. Though extremely rare, meteorite or asteroid impacts into the ocean can also cause a tsunami. When a large meteorite strikes the ocean, the force of the impact can displace a significant amount of water, generating waves that can spread across the ocean. While these impacts have the potential to create very large tsunamis, they are much less common compared to other causes like earthquakes and volcanic eruptions. How do tsunamis travel? Once generated, tsunami waves travel at great speed across the open ocean. However, because of the vast distance between the source of the tsunami and the shore, the waves often go unnoticed at sea. As the waves approach the shore and enter shallower water, they slow down and increase in height, sometimes forming waves that can reach over 30 meters or more in some extreme cases. Tsunami impact on the shoreline. When a tsunami reaches land, it can cause massive destruction, often with multiple waves hitting the same area in succession. The first wave is not always the largest, and subsequent waves can be more destructive. Inundation. Tsunamis can flood large areas of land, damaging buildings, infrastructure, and crops. The powerful water can erode coastlines and wash away entire communities. Surge tsunami waves can move rapidly inland, sweeping away anything in their path. These waves are often accompanied by a backwash of water that can drag debris and people back into the ocean. Tsunami warning systems. Because tsunamis can be so destructive, many countries with coastlines at risk have early warning systems that use seismic data to detect earthquakes and measure changes in sea level. These systems can give people a warning, often ranging from a few minutes to a few hours, to evacuate coastal areas. However, not all tsunamis can be predicted, especially if the triggering event occurs in a remote location or if there is no seismic activity before the tsunami. So major causes for tsunami occurrence is when there is a large, sudden disturbance that displaces a large volume of water. The most common cause is underwater earthquakes, but other events like volcanic eruptions, landslides, glacier calving, and even asteroid impacts can generate tsunamis. Once created, these waves travel across oceans and become more dangerous as they approach the shore, often resulting in catastrophic flooding and destruction. Understanding these causes and having early warning systems in place is essential for minimizing the impact of tsunamis on coastal communities.